The crossplane or crossplane is a crankshaft designed for piston engines with a 90-degree angle between the crank throws. The crossplane crankshaft is the most popular configuration used in V8 road cars. Crossplane crankshaft could be used in many cylinder configurations to have an evenly spaced firing as long as the number of cylinders is multiples of 4 in 2-stroke engines, or multiples of 8 in 4-stroke engines. Unless the crank pins have big end phase offset, the V-angle requirement must be met for an evenly spaced firing on V configurations as listed below. 2-cycle, L4, L8, L12, L16, V4, V8, V12, V16, flat 4, flat 8, flat 12, flat 16, etc., 4-cycle, L8, L16, V8, V16, flat 8, flat 16, etc. However, crossplane crankshaft has been used on other 4-stroke configurations like L2, L4, V2 and V4 engines with unevenly spaced firing when its prominent advantage of smaller secondary vibration, which increases exponentially with crankshaft rotational speed, outweigh the disadvantages like the imbalance in firing spacing and the increase in rocking vibration. 90-degree V8 crankshaft. The most common crossplane crankshaft for a 90-degree V8 engine has 4 crank pins, each serving 2 cylinders on opposing banks, offset at 90 from the adjacent crank pins. The first and last of the 4 crank pins are at 180 degree with respect to each other as are the second and third, with each pair at 90 degree to the other, so that viewed from the end the crankshaft forms a cross. The crank pins are therefore in 2 planes crossed at 90 degree, hence the name crossplane. A crossplane V8 crankshaft may have up to 9 main bearings in the case of an 8-throw design, and usually has 5 bearings supporting 4 throws each with a shared crank pin. Crossplane V8 engines have unevenly spaced firing patterns within each cylinder bank, often producing a distinctive burble in the exhaust note, but an even firing pattern overall. Their non-sinusoidal imbalance, owing to the lack of pistons that move together in the reciprocal phase, is half as strong and double as frequent as in the flat plane design that does have piston pairs moving together. In the absence of balancer shafts, the disadvantages include rotating plane imbalances on 1 rotating mass, 2 reciprocating mass, 3 torque generation and 4 compression, all of which generate rocking vibrations. These imbalances can be countered to varying degrees with heavy counterweights on each crank throw, so most crossplane V8s have very heavy crankshafts. Early Chrysler Hemi 5.8 had heavy counterweights, but the middle 2 positions on both sides of the center main bearing did not have any counterweight, as these positions are located close to the center of engine and deemed ineffective to counter rocking motions. Another disadvantage is the aforementioned unevenly spaced firing within a bank of 4 cylinders, which can be mitigated by what is called a bundle of snakes as described below. The other prominent design for a V8 crankshaft is the flat plane crankshaft, with all crank pins in the same plane and the only offset being 180 degree. Early V8 engines, modern racing engines and some others have the flat plane crankshaft, which is similar to that used in a straight 4 or flat 4 engine. They lack the V8 burble but have double as strong secondary vibration of the crossplane design, and do not require the large crankshaft counterweights. Inherent balance of the reciprocating mass is like a pair of straight 4s, and modern designs often incorporate a balance shaft for smoothness. When built without balancer shafts that add to the overall rotating mass, flat plane designs have the least flywheel effect of any V8s, which allows them to be quicker to rev up and down. The crossplane design was first proposed in 1915, and developed by Cadillac and Peerless, both of whom produced flat plane V8s before introducing the crossplane design. Cadillac introduced the first crossplane in 1923, with Peerless following in 1924. Bundle of snakes equals. The characteristic burble of a crossplane V8 comes from the exhaust manifold design which merge all 4 exhaust ports on each bank of 4 cylinders into one exit. On a 4-stroke engine, each port generates the exhaust pulse once every 720 degree of crank rotation, and they need to be paired with the pulse generated at 360 degree phase difference in order to result in an evenly spaced exhaust pulse. This is needed not only for a clean exhaust note, but more importantly for uniform scavenging of residual gas in the cylinders, which is needed to fill the cylinders with the same volume of intake, that is essential for uniform combustion and torque generation. While the firing of the 4-stroke Crossplane V8 is evenly spaced overall, the firing order on the LEFT and IGHT banks are LRL, LRL, or RLRL, with each L or R ignition being separated by 90° crank rotation for a total of 720° for 8 ignitions. As can be seen by counting 4 characters to the right of each L or R, the cylinders that fire at 360° phase difference reside on the opposite banks on the Crossplane V8, so long equal length exhaust pipes that merge the pairs are needed to achieve uniform scavenging. The exhaust design that achieves this is referred to as tuned exhaust. One of the earliest examples of a tuned exhaust for Crossplane V8 was on 1.5-litre Coventry Climax FWMV MKI and MKII in the early 1960s. While many racing Crossplane V8 engines had exhaust ports on the inside of the V-angle to make these exhaust pipe lengths shorter, Ford GT40 made the concept on production-based V8s famous with an elaborate arrangement of long exhaust pipes nicknamed Bundle of Snakes. Inline 4 Crossplane Crankshaft. Unlike in a V8, crossplane arrangement in inline 4 engines results in unevenly distributed firing pattern, so the use tends to be limited to extremely high revving engines, where the advantage of less secondary imbalance outweigh the irregular firing interval disadvantage. Please see engine balance article for details. 2009 plus Yamaha YZF-R1 The 2009 Yamaha YZF-R1 motorcycle uses a crossplane crankshaft and user balance shaft geared off the crankshaft at crankshaft speed to counter the inherent rocking vibration described above. A crossplane crank had been used in Yamaha's M1 MotoGP racing models in the past. Yamaha claims advances in metal forging technologies make this a practical consumer product. URS engine the so-called Pfaff-Kuhn straight 4 engine, as used to relative success in motorcycle and sidecar racing from 1968 by the private URS racing team, was also a crossplane type. It was a different configuration to that normally used in a V8 or indeed in the Yamaha above, with 2 of the throws being swapped around, that is the throws may be described as being at absolute angles of 0, 90, 180 and 270 degrees, versus the more usual 0, 90, 270, 180. This results in a slightly reduced primary rocking couple, but introduces higher-order couples of much lower magnitude. The different layout was primarily chosen to reduce the impact of the inertial torsion inherent with crank throws spaced 90° apart due to the pistons being accelerated, given this engine was meant to be high revving and inertial forces scale as to the square of engine speed. The reduction in torsion was achieved by splitting the crank into 2 separate parts, geared together, from their respective midpoints, via a counter shaft, from which power was delivered to the gearbox. It is likely this inertial torsion within the crank is the reason for Yamaha citing crank forging improvements as a reason for the crossplane crank being viable in a road bike. It is less of an issue in the V8 because each throw is shared by 2 pistons already offset by 90°. Firing intervals crossplane crankshafts used in a 4-stroke, 4-cylinder engine result in uneven firing, since the natural separation of ignition events is 180° in such an engine. The firing intervals for the Crossplane 1 and URS engines are 90-180-270-180, but other intervals are possible including those due to so-called Big Bang firing orders. The uneven firing is the cause of the distinctive sound of this configuration, which is superficially a combination of the 270-450. 180-540 and 90-630 intervals, the dominant interval perceptually being the 270° one. The 90° throw separation would make the crossplane crank a natural choice for a 2-stroke straight 4, providing the advantages of both evenly spaced firing and less secondary vibration when the increased rocking vibrations are countered with a crank speed balance shaft. Twin-cylinder crossplane cranks. Twin-cylinder motorcycle engines can also use the crossplane concept. used in all inline twin-cylinder two-stokes including quite large capacities such as the 509/8cc Scott or 409/8cc Suzuki TGT 500. Most early Honda four-stroke twins including the 450cc's Black Bomber, and CB500T made before the 1977 Dreamhawk had 180°-degree cranks. Due to small size, the rocking couple was acceptable without a balance shaft, particularly when compared to a similar-sized 360°-degree twin without balance shaft. As the 400cc's Dreamhawk CB250/400T was to replace the four-cylinder CB400F, to obtain similar smooth running of the four, it was a 360°-degree twin with a balance shaft. The Triumph Bonneville T100 and the 1991 Yamaha TDM 850 motorcycle used crossplane crankshafts with specially designed balancing systems. British twin motorcycles of the 1950 to 1980 era, and Yamaha 650 and 750 motorcycles of the late 60s through the early 80s, have been modified to use crossplane crankshafts under the terms offset crankshaft or rephased crankshaft, with notable success in reducing the vibration inherent with a stock 360°-degree vertical twin. These modified engines do not use additional balancing systems but are smoother with lighter flywheels. Recently also used in small motorcycle engine, such as Yamaha R25, R3, MT25. See also, Cadillac V8 engine, V8 engine. References. External links, V8 engines, a crossplane engined URS sidecar outfit being warmed up.